Good afternoon. Okay, so today we're going to look at the outline for our related rates and graphing quiz. So there's 5 questions on this. 4 of them are on related rates, and 1 is on the graphing stuff that we did just the hand-in for in Unit 4. Okay, I didn't have a quiz on that, so I'm going to put it on this quiz, just 1 question. So let's outline that, and we'll do a little bit of practice as well for this. Oops. So let me just pop open my reference page here. All right, so I haven't sent this out yet, but I will presently. So this is the outline for the related rates quiz and polynomial graphing quiz. Okay, so I'm just going to go through what the questions are and do kind of like a similar one or a close one to that. Okay, so the first thing that we're going to do in there is we're going to have a polynomial graph. And you're going to graph it, or not graph it, you're going to sketch the graph. So it's not drawing it on a graph, but just kind of sketching it and labeling everything. So, and that's 6 points. Okay, and I'm going to require you to find the critical points, the inflection point, the max and min values, okay, sketch the graph. Okay, just like the hand-in we did in that unit. Okay, so an example. Okay, so let me just get my preview up here because I didn't turn it on yet. And then we'll do a little. Okay, so I'll move that out over here. It doesn't show me the preview that it used to. Okay, so I've got an example here. I think that'll work out fairly evenly, at least for the critical points anyway. So let's do y equals, okay. Y equals x cubed over 3 minus x squared minus 15 plus 20. Let's do that one. Okay, so the first step in doing these, as you know, is critical points. Critical points are found by taking the derivative and setting it to 0. So we got to do y prime. So this is 1/3 times 3x squared, because that's 1/3, minus 2x. Oh, this is an x here, sorry. Minus 15 plus whatever. So when you multiply these two numbers together, you get x squared minus 2x minus 15. Okay, and then we set that to 0 to get our 2 critical points. So in this case, we can factor this one. That's why I picked this one. X minus 5, x plus 3. Okay, so that means x can equal 5 or x can equal 3. That's where our negative 3, our 2 critical points come from. Okay, and then you take your calculator out, 5 to the power of 3 divided by 3, minus 5 squared, which is 25, minus 15 times 5, plus 20. So you get 5 and negative 38 and a third for our first one. My calculator works in fractions, so it helps out a little bit. Okay, and then if you do negative 3, x equal negative 3, so you go negative 3 to the power of 3. So that's negative 27 divided by 3. That's negative 9 minus negative 3 squared, which is minus another 9. This gives us negative 18 minus 15 times negative 3, which would be like adding 45, and plus 20. So I get 47. So negative 3 and 47. So there's our two critical points. Now we could tell which one's a maximum and which one's a minimum based on the size of the y value. So we don't necessarily have to do the sign analysis on this one, but we can see that this is going to be a min. This will be a max because it's up high and this one's down low, right? Okay, so that's kind of there. And if we do the inflection point, to do the inflection point, we have to do the second derivative. So we need now y prime prime. Okay, and the second derivative of this. So that would be 2x minus 2. So you can see why I kind of made it look that way, so it will work out even for us today. Okay, and then so if we set that to 0, so 2 equals 2x, x equals 1. So we have an inflection point at 1, and if we plug in 1 up there, we get 1/3 minus 1 squared, which is 1/3 minus 1, which is negative 2/3. So we have negative 2/3. We add 1 or subtract 1 times negative 15. So 1 times negative 15 is minus 15. And then we add 20 to it. So we get 4 and 1/3. So our inflection point is at 1 and 4 and 1/3. Okay, you can use decimals if you want when you're doing this. That's fine by me. Okay, whatever you decide. So now that you've got your inflection point, your max and min values, and your critical points, and you know the end behavior is a cubic one with a leading coefficient of positive, so it's going to go up from left to right like this somehow, okay, because that end behavior is going to be down here and up here. We can now sketch the graph. Okay, so for sketching the graph here, we got 5 and negative something. So down here, over here we have a minimum, 5 and negative 38 1/3. Okay, and then somewhere at negative 3, we've got 47 here. So negative 3 be about here, and 47 be about there. So we've got a maximum here. Okay, and in between there, at 1, okay, we have an inflection point. So 1 and 4 1/3, so it'd be about here somewhere. And that's where the concavity is going to change. So we're going to get something that looks, we're not sure where it crosses the x-axis there, but it does. We don't know if it crosses above or below there, but it comes down like this. And then at this inflection point here, it's going to change to curving upwards. And go like this. So, something like that. So this inflection point here is negative, or sorry, not negative, 1 and 4 and 1/3. Okay, I didn't ask for concavity or anything like that, but if I asked for that, it'd be concave down from negative infinity to this inflection point, and concave up from this inflection point 1 all the way to positive infinity. If I asked you where it's increasing and decreasing, it's increasing, decreasing, increasing. Okay? So that's the first question, 6-point question. Simple example there. We'll have a similar one to that. Okay, so let's just pause there, and I'll go on to number 2 here, but I got to get my sheet up. So let me pause for a second. Okay, so the next one is a related rate question, 4-pointer. So it could be like a max min question. So it could be like a volume of a box question, a fencing question, cost of a fence question, or it could be a printed poster question, max and minning the area of a printed poster, something like that. Okay, and that's worth 4 points. So that's number 2. So the most common one that I usually stick on there is like the perimeter area one. So number 2 is a max min cost question, or area question, or something like that. We'll say cost question. Okay, and that'll be worth 4 points. So let's do an example of that. Okay, let's say a farmer encloses a rectangular pen. Okay, with an area of, let's say, 340 square meters. Okay, material. Okay, for the north and south fence is $15 a meter. Okay, and the material for the, let's say, east and west fence is, let's say, I don't know, $22 a meter. Okay. Find the dimensions of the pen to minimize cost. Okay, so that's the one we're going to have to derive. Everything else we're going to have to use to manipulate around. Okay, so if we're going to say, we're going to draw a little picture here. Do this one. Okay, it would be similar to one on the exam. So let's say we don't know if it's longer going north, south, or east, west. So we'll just guess. Okay, probably guess. So this is 270 meters squared in here. And let's say that this, let's say north-south line is so many meters, and this is so many meters, and the east-west line is so many meters and so many meters. So we know that the north-south times the east equals 270 square meters. Now we have to come up with a cost. Okay, so this one is the north times 15 dollars a meter. This one is times $10 a meter. Okay, so, why did I put 270 there? It's 340. Can't read my own writing. Right? Sorry, guys. 340 meters squared. Okay, so we have to do the cost. So the cost is going to be 10 times E plus 10 times E for these two sides plus, why did I put 10? See, now I read the one off the exam and I pretty much used that number. So you guys got a hint already. I'll have to change that. It's supposed to be 22, right? 22 for this way. Right? $22 a meter. So 22E plus 22E plus 15N plus 15N equals the cost. Okay, so if we simplify that down, we've got 44 east-west plus 30 north-south equaling the cost. Now, in order to take the derivative, we have to change N into E or E into N, so that's what we use this area for. Okay, we're going to say that N is equal to 340 divided by E. Okay, and we can then plug that in where the N is here. Okay, so we're going to plug that in here. 44 E's plus 30 times 340 over E is going to equal the cost that we're trying to minimize. Okay, so we got to take a calculator out, do 340 times 30. $10,200. Okay, and this time we're going to bring that E up and write it as E to the power of -1 because we're going to end up having to take the derivative anyway. E equals cost. So now we're going to take the derivative of cost and set it to 0. So the derivative of 44E is 44. Okay, plus -1 times 10,200 E to the power of -2. Equals 0. Okay. Okay, so then we're going to minimize the cost here. So we have to take that one. We got 44 minus 10,200 E to the power of -2 equals 0. So we got to bring this over to the other side so that we have it like this. Okay. And then we're going to write E power of power squared on the bottom. Okay, so we're now putting that back on the bottom so that we can cross multiply it. So then we got 44E squared is equal to 10,200. Divide by 44 on both sides to get 231 and 9/11, or 231.8. Okay, and then square root it to get E. So that's going to give us E equals 15.2 meters, rounding off to the nearest tenth. So that means that if that's 15.2, we have to find out what N is now. So N is going to be 340 divided by 15.2. 22.4. So then that means meters. So that means our dimensions are 22.4 by 15.2. Okay. And if we multiply 22.4 times 15.2, we should get our 340 within rounding reason of our area. Okay, so that's our dimensions. Length of 22.4, width of 15.2 meters. Okay, so that's the second question on there. Okay, the third question deals with related rates distance problem. Okay, with like the squirrel running up the tree type example. Okay, so let's do that on the next page here. Okay, question 3. Is a related rate distance problem. Okay, you're going to be using Pythagorean theorem. You gotta spell that right and put a capital in there. Okay. Don't want this one to go too long. That's 20 minutes, so I'm not going to do an example of each one of these, but think of, look at the example that we did with the elevator and person at the base of a building. Or look at the truck and car example. Okay, approaching. An intersection. Okay, so I'm not going to do an example of that one because the other two are related rates as well. We'll do an example of that. I don't want this to go more than 30 minutes or 35 minutes today, so I don't want to burn up the whole class. Okay, so that's a third question. So look at those two, and that's going to be worth 4 points as well. Okay, the next one is going to be a cone question. A cone question using the cone. And the last one will be a sphere question, okay? So question 3. 4, pardon me. 4 is a related rate cone question. And question 5 is a related rate sphere question. And I'll do each of them is worth 4 each. You can study those, but I'll do an example of a sphere question. Okay, and you'll need to know the volume formulas for spheres and cones. Maybe I'll just type them. I don't have them on this quiz right now, but maybe I'll send a sheet with them on there. So let's do a cone question because the sphere questions are easier because there's only one. The radius is the only thing changing. So let's do a cone cup question or a pile of grain question that's in the shape of a cone or something like that. So let's do that. Say a right side first there. Sorry, guys. I had my example and I just deleted it by pushing the button there. So I got to get another one. There we go. Okay, let's say a cone cup as measurements of height equaling 12 centimeters, and diameter, be careful, no radius, I'm giving you a diameter. It's not a trick. It's a bit of a trick, okay? Of, let's say, 10 centimeters. Okay, a volume of water, we'll say, is flowing in at 16 cubic centimeters a second. Okay. Find the rate at which the height of the liquid is rising in water when it is half full, so 6 centimeters from the base. Okay, so the first thing we got to know is we got to know the volume of a cup. So it's a cone. It's 1/3 pi r squared times h. That is the volume of our cone. So now we draw our cone. Okay, the diameter here is 10 centimeters. Therefore, r is 5. Okay. And then this height that we want here, we want it when it's 6 centimeters, even though the total height is 12 centimeters. Okay, so the first thing we got to do is we want to get we know that the volume that's going in. So we want to get this in terms of H. Okay, so we have to write R in terms of H. So R in terms of H. R over H, according to the cup, is 5 to 12. Okay, so that means 12 R's equals 5 H's. Okay, now we want to place it in here so that we're not left with nothing but H, because we want dH dt. We want to find dH dt. We're trying to find dH dt. We want to know how fast it's rising, okay, when the cup has a height of 6 centimeters. So we have to replace this R with that. So we have to solve for R here. So R is equal to 5H divided by 12. Okay, so that's what's going to go in there to redo the volume question. So it's pi over 3 times 5 over 12 H squared times H. Okay, so we're just going to do some algebra here. Okay, so 5 squared is 25, 12 squared is 144. that's squared. So now we can do some simplification. Okay, so we got pi. We're going to go 25 pi h cubed on top over 3 times 144. $432. Okay, so now we got to do dv dt. Now we take the derivatives using differentials. dv dt equals 25 pi over 432. Okay, just taking that number, then I'm taking the derivative of this times 3 pi h squared dh dt. Okay, now we got to do some simplifications here. Okay, so that's 75 pi h squared over 432 times dh dt. Oops, not dht, dh dt. Okay, now we can plug in our numbers. Okay, dv dt was 16 cubic centimeters a second. Okay, this h number, 75 pi times 6 squared, because that's the point at which we're interested in when it's rising, times dh dt. Okay, so we have to simplify this number. Okay, 6 squared is 36 times 75 times pi, 2700 pi, divided by 432. 6 1/4 pi. It's nice to have a calculator that does everything in fractions, but if you want that as a decimal number, 19.63 dHdt. Okay, and this is centimeters cubed squared. Okay, so that's 19.63 centimeters squared dHdt. Okay, and then we just divide both sides by 19.63. And we get 0.81 or 0.82 or 0.8, whatever you want. I'm going to put 0.82. And then the centimeters squared cancels out some of them, centimeters per second. So is how fast, and that's probably behind my head because I can't do the preview anymore where I can see the writing, so I'll move it up. So this would be that. So the cone one's a little harder. The Saphir one will be the same, except it has different formulas for circumference and surface area, but it only has one variable to worry with. So there are 5 questions. Okay. The last 4 are worth 4 marks each. Oh, sorry. Pardon me, I was wrong. The Saphir question is worth 6. Okay. Question 5 is worth 6. 4 is worth 4. Question 5 is worth 6. Okay. Because it's got 3 parts to it. One deals with circumference, one deals with surface area, and one deals with volume. All 3 of those. So 2 marks each. Okay, I'm not going to do one of those because you can look at that back in our notes. But that'll give you an idea of what's on that quiz. I'm going to send that out pretty soon here. I know that there's a couple people that are all caught up and right with me right now. But I also know that there's still a few people that are, I had just handed back their last assignment to. So there's as much as 2 weeks difference between some people in calculus and some people not in calculus. So I'm going to slow down a little bit here and send that out and then try to get everybody closer together. We've got 1 unit left. I intend to finish in early June so that we don't have to do any work in the last couple of weeks, and maybe even write the final early if you feel like it. Okay, so good luck on the quiz.